everyone! This video is all about a nonparametric test. On this video, we can learn on how to compute a nonparametric test. But before computing a nonparametric test, first, we need to define what is nonparametric test. Nonparametric test. Nonparametric test usually means that we know the population data does not have a normal distribution. So, okay, let's proceed to the example of a nonparametric test. The first and second quarter grades of 12 students in math are as follows. First quarter, we have 80, 90, 84, 77, 94, 82, 87, 79, 83, 91, 76, and 88. For the second quarter, we have 91, 86, 90, 94, 84, 77, 80, 93, 95, 86, 79, and 86. The question is there a difference between the median values for the following sets of their grades in first and second quarter? The appropriate method for the nonparametric test for this question is, our highlight is all about the median, so we need to compute the difference between the median values of the two following sets. So we're going to use Wilcoxon signed ranks. So step 1, we need to subtract their second quarter grades to first quarter grades. So we need to put this one equals C2 minus B2. Then the result is 11. So we need to click this one and copy to find the result of all data. So here are the result. So after computing the differences of their two sets of data, we need to place the differences in order here, and then we need to rank them. So first, we need to put their rank. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we're done for the ranking. So next thing to do is we need to get their difference but in order. So in placing difference in order, we need to ignore the sign for the rank order. So next is 2 and 3, 4. Then so we have two tied ranks, 5. Then 5, 5. Next is 6, then 7, next is 10, then 11, 12, 14, and the last is 17. So these difference in order are all positives because we ignore their signs. So in the next column, so we need to put their signs. So in here, it is positive. So we need to base the difference. So the value of 2 in here is, the sign is negative 2. So we need to put this negative. So our 3 is positive. Next is our 4 is negative also. Our 5 is negative. Same thing with the last, so negative. And 6 is positive. 7 is negative. And 10 is negative also. Then 11, we have positive. So our 12 is positive. Then 14 is positive also. And the last, the 17 is positive. So next thing to do is, so here we're going to calculate the Wilcoxon signed rank sums. So first is we need to calculate the sum of ranks of the negative differences. So we don't need to compute the difference in order value. Instead, we're going to add or the summation of the rank for the negative sign. So we have rank 1 for negative. It's 1. So next negative is 3, the next negative is 4, and we have next negative is 5. So the thing is, they are two tied ranks. So, it's not 4. Instead, it is 4.5. Same with this one. They are 4.5. So, next is 7. Next is 8. So, those ranks are negative. The summation of these ranks is equal to, their summation is 28. Because it's 3 plus 4.5. Oh no, we have this 1. So, it's 1 plus 3 plus 4.5 plus 4.5, 7 plus 8. So, their summation is 28. So, next is, we need to compute or calculate the sum of the ranks of the positive differences. So, we have 2. It's positive. And we have 6. Next is, we have 9. Then, we have 10, we have 11, and 12. So, the summation is 2 plus 6 plus 9 plus 10 plus 11 plus 12 is equal to, their summation is equals 50. So we are done for computing the summation of negative differences and the positive differences. So we have two tied ranks. So we need to use the normal approximation with Wilcoxon signed ranks. According to the rules of normal approximation with Wilcoxon signed ranks, if the number of observation or pairs is greater than 20, we can use a normal approximation. So, the formula is n times n plus 1 divided by 2. So, our n is 12. So, we need to substitute our n. So, 12 times 12 plus 1 divided by 2. So, the result is 78. So, it's greater than 20. So, this time, we need to apply a normal approximation with Wilcoxon signed ranks. Okay, and the last thing to do is we need to get the z-score. So, for the z-score formula, we need to use, but there are several modifications or considerations for the z-score formula. First thing to do is we need to use the smaller of the Wilcoxon's summation of the negative differences or the positive differences for the test statistic. Next is use the following formula for the mean. So here is the formula, n times n plus 1 divided by 4. So next is we need to use this formula. The square root of n times the n plus 1 times 2n plus 1 divided by 24. So we have two tied ranks. We must reduce by this formula t, or it symbolized as tied. Two tied ranks, so t cubed minus t over 48 for each of the tied ranks. So we have two tied ranks, and this is 4.5 plus 4.5. So 8 minus 2. Why it is become 8? Because we have two tied ranks, so we need to substitute the value of t, 2. So 2 cubed is equal to 8 minus 2 divided by 48. So 8 minus 2 divided by 48 is equal to 0.125. So next is we need to substitute the value to get the z-score. So this gives a z-score of z equals, so 28 is the summation of the ranks of the negative differences. So minus 12 times 13 divided by 4 over the square root of 12 times 13 times 25 divided by 24 minus 0.125. So equals, so the result is 28 minus 39 divided by the square root of 162.5 minus 0.125. Then 28 minus 39 is equals to negative 11 over 162.375. So next is negative 11. So the square root of 162.375 is equal to 12.74. So negative 11 divided by 12.74 is equal to 0.86. So the value of our z-score is equal to 0.86. So we need to ignore the negative sign. So it is automatic a positive. So it is 0.86. This time, this is our graph. So our z-score value is 0.86. So from the z-table, we get the value of p-value, which is 0.194. So looking up this z-score in the z-table, we get an area of 0.6664 equal to a two-tailed p-value of 0.334. So there's an indication that the medians are significantly different between the two sets of their grades. And so that's the end of computing of the non-parametric test, and I hope you learned something from our tutorial. So thanks for watching and God bless.